Welcome to Post Cloud, where we talk about all things cloud and the future of cloud and what we're doing today and what we're doing tomorrow. My name's Chris Krantz. I've been in the tech industry for a number of years. The past 5 to 10 years, I've been really focused primarily on cloud native technologies, and more recently, very much in the application side of things. I'm joined by my co host, Stephen.
Hello, Stephen. I've been working in IT also about 20 odd years now and have kind of gone through from managing lots of physical stuff to lots of VMs to trying to orchestrate lots of VMs. And I was quite excited when I discovered that I could orchestrate lots of containers. And that's what we're going to be talking about today. Perhaps the most popular container orchestrator on the market at the moment, Kubernetes.
So I first came across Kubernetes when I was working as an end user. You've probably heard me talk about this a few times. We were packaging up our application in order to ship it around the world. It wasn't a simple application. It was actually quite a complex application with lots of different components. And we needed to do that in a way that was repeatable and a fairly standard way. And that's my kind of first interaction with Kubernetes.
My first real memory of it was looking for ways that we could orchestrate a whole bunch of containers, because up until then we'd had some scripts and we'd started to containerize our software because we were shipping automation frameworks, and we realized that was an easy way to ship something that would automate physical assets. And the way to do that we found most straightforward was to package the software as containers, and we had our database in one, our web server in another, automation frameworks in another. And we were even, shipping additional modules and plugins as containers so that we could easily manage them as the same media format. And these days, you can look at Rancher, K3S, OpenShift. There's all these different flavors, and they're all ultimately at Kubernetes under the hood, right? And that's forgetting the public cloud flavors.
So last time we were talking about containers, and obviously I was talking about samosas, which I love. How can I stretch that to make it fit into Kubernetes? So with samosas, you want to make them repeatable. So what you do is you have a recipe. You have a certain defined list of things that go into the samosa. You have your pastry, you have your potatoes, your vegetables, your spices, and that helps you make it. It helps you make it repeatable. It means if you eat a samosa, I can instantly replace it with a new one because I've got the recipe for that. I can give that recipe to Stephen, and Stephen can make fantastic samosas as well. That's kind of what we're talking about Kubernetes, but not really, because I don't think that analogy properly works. But I wanted to talk about samosas again. So with Kubernetes, first of all, you have templates for your applications. So I want to be able to create these containers that are built into or designed into application blueprints.
If I was to describe Kubernetes, I'd describe it as a system of controllers. You take the notion of immutability that you have with a container, and you extend that immutability to a pod. A pod is a group of containers sharing namespaces, and that pod allows you to have network attachment and storage attachment to your containers. It provides somewhere where you can attach log reading, where you can do security analysis, and so forth. And every object in Kubernetes tends to follow this pattern. The leaf nodes, the bits that are deployed that are doing the work, those are immutable. You can create them, you can destroy them. If you want to change it, that's the job of a controller. And the controller handles a set of templates, and it takes those templates and instantiates them into real things that are touching the real world. The controller handles the non-immutable parts, the changing parts of your ecosystem, the number of pods you want to deploy. It handles the images you want to deploy in those pods, and it encapsulates those in templates. So Kubernetes is an orchestrator of immutable workers, and each of one of those workers will have some sort of specialized controller, and you delegate the work to that controller. You don't have a giant monolith because it's a service for microservices that's run as a set of microservices. So every small group of similar services will have a controller that deploys and manages it. And you can delegate that, which ensures that you don't get security problems because you don't have a controller that's shared between secure and insecure objects. And it allows for multi-tenancy by the same means as well, because tenants are not forced to share controllers.
Why do we need this? What is it that we're trying to achieve here? If you think back to some of the analogies and some of the stories we've talked before, you've got these applications that could be quite big and complex applications, as Stephen was saying there, but they're broken down into these microservices parts. Each of those individual parts needs to have certain dimensions and certain rules to apply it. You I need a minimum of 1, I need a maximum of 20, I need it to be split across these locations, I need these certain security rules, it can talk to that. That's one individual component. Now multiply that out by the 20 different components that are needed for an application, and you've got quite a complex thing that needs to be really, almost autonomous in the way it operates, in the way it self recovers, in the way it scales. And really, that's where the orchestration comes in, and that's where Kubernetes has come into shine. Now, do you need Kubernetes to do that? And the answer simply is no. You can do that with other things, but Kubernetes has become a very popular way of doing this across the world, where people are doing microservices, people are doing cloud native style technologies. And in theory, although this is something that Stephen and I have slightly different opinions on, but in theory, Kubernetes also gives you something that provides that kind of vendor neutrality. So you can move your workloads around, whether it's from a DR or from maybe or maybe not a live perspective. So there's a lot of advantages to Kubernetes. There are some disadvantages as well. Today we're going to be talking more around a bit more detail about Kubernetes, and maybe drilling into some of those kind of discussions of should you, shouldn't you, and what are the different options there. There's different scenarios where you might start using containers and then might think about using orchestration.
Let's start at the small end. You've got a developer laptop, an edge device, or a very small set of servers. You could be using perhaps the old style Docker desktop application to get started if you're on a Mac, to get containers up and running and experiment with them on your laptop, or maybe you're running Podman. Maybe you're even running an embedded version of something like K3s on your desktop, which is a very lightweight Kubernetes. And then you can transition that same template, maybe as a Helm chart, and take it and run it elsewhere. In the Kubernetes world, those types of edge applications are served pretty well by something like K3s or maybe RKE2. And larger clusters, as you go into the enterprise, you might be using something like the Tanzu offerings from VMware or OpenShift from Red Hat that enable you to have a much richer ecosystem. Now, alongside this modular set of building blocks that I mentioned, where you've got immutability, something else that you might hear a lot of when people are talking about Kubernetes is declarative. The declarative methodology is a way of managing configuration by stating that you want a specific outcome and relying on some piece of code or intelligence to make its way towards that outcome for you. And it provides a way that you can integrate a lot of different logic to provide similar outcomes. For example, if you're attaching storage or attaching network services, you can have the same type of implementation with lots of different routes to that outcome from a different vendor using a different type of technology, maybe a little dummy plugin that lets you run it locally versus a huge enterprise behemoth that actually happens in production. And they can all look the same because they've got that same declarative wrapper around.
I think this is one of those topics that I found hardest to wrap my head around. I'm a tinkerer at heart, so I'm used to taking that journey of, okay, I'm going to configure this, then I'm going to configure that, and then I've made a mistake here, so I need to go back and reconfigure it. So defining that the upfront outcomes kind of in a YAML file. You'll hear us talking about YAMLs. You hear Kubernetes talking about YAML. So YAML simply is yet another markup language creatively. And it's all about the white space. If you don't have the white space properly, your YAML will break. For me, that was the hardest, the biggest learning curve. I understand containers, I understand the networking, the requirements to do that. What I've got to do is write an entire YAML file in order to get all these components to do what I need to do.
I've seen a lot of developers do this. And in particular, you'll go onto a live system and make a change because that's what you want to happen. You go in and change the live system, but you don't realize necessarily when you start working with Kubernetes that you are not the only hand on those controls. So that forces the developer to think about not tweaks to the system, but writing the whole configuration out longhand, which can be very onerous. And that's painful when you start working with Kubernetes. But over time, you'll probably realize that what you're actually looking at when you look at this huge, lengthy configuration is a composition of lots of little fragments all joined together. And once you can isolate where you need to make the change in those little fragments, you realize that, it's just a 1 or 2 line change. The hardest part is getting around the terminology.
The trouble there is we've got to relearn some of the things that we've done forever. You have a production issue, you log into the box, you make changes in order to fix production. You shouldn't do that in Kubernetes anymore. Can you do that? Yes. And that's part of the problem. So if you log in and actually change your code or maybe change your config directly in your container, Kubernetes has no knowledge of that. And the trouble is if you do that on one component of a big cluster, you've deviated your standard configuration across there, but no one knows that until something rolls out a new patch, and then all of your work is overwritten. I used to do a lot of security in the Kubernetes space, and one of the things we'd often come across is the traditional way of approaching security is to come in and do patches and fixes, and maybe you have a security tool that automatically makes changes when it sees an issue. The trouble is that becomes an anti-pattern or something you shouldn't do in Kubernetes, is because you're deploying something that's immutable. Another tool is coming on and making a change. Every time you do a deployment, that change is going to get overwritten. So now you've got two tools that are continually overwriting each other and changing the configuration.
That reconciliation loop is troublesome, but at the same time, it's going to be doing your work for you at 3 a.m. when you're asleep. This opens the door for stuff like GitOps, where you can keep track of what's happening in your environment.
So Git, that way of checking in, checking out code, and having your code repositories with change control and the rest of them, combined with operations. So I'm codifying all these operations. If I'm going to do security patches, I'm going to put it into my Git operations, my Git source code repository, and then those patches are downloaded and deployed across the environment. You'll hear many people talking over and over again, you don't deployments on Friday. Of course, you absolutely don't do deployments on a Friday afternoon. The thing is, you should never do them, but you need the ability to do them. Because someone doing a crypto mining your environment and hacking your environment doesn't care that it's Friday afternoon. If you've got a security fix that you need to do, you need to be able to deploy on Friday afternoon with confidence.
And that takes us, I guess, neatly to the topic of operators as well, which fit in with some of this control loop, where you have a dedicated control loop managing the functionality of one niche area of code. And the operator might be doing something very specific. Maybe it's working to take an NVIDIA GPU and connect it to your Kubernetes cluster and make it available and control the resource allocation for different users. And operators are triggered via webhooks in Kubernetes, and there's a callback. So if there's a specific bit of annotation on something, it can be listened to by an operator. The operator effectively registers an interest in certain objects, and when those objects are changed, that is then fired back to the operator, and the operator can step in almost like an expert, like an SME in your team, and step in and be like, I'm the one that knows about GPUs, let me give you a hand. And it'll run through that and set it all up, and you get the best practice and correct implementation from that operator. So that means you can have, on the face of it, a very simple environment with just plain containers, but you can easily supplement that with SME knowledge that takes engineering best practice and implants it into your Kubernetes cluster.
You can operate Kubernetes without that. You can have relatively simple Kubernetes deployments with simple cluster, simple namespaces. But as you get more and more into it, as you get into a more complex or a more demanding environment, that's where the operators are really going to come into their own. And like Stephen said, it just helps you out in doing a lot of those more complex operations that could be quite routine once you get up and running and going. But actually, let's take a little bit step back. At a kind of a fundamental layer, how would you describe some of the core components within that Kubernetes cluster?
We've got an API that's exposed that lets us change all these immutable things and the templating engines around them. And then we've got storage that the API uses to persist what you've asked it to do. So you've got etcd, which is a key value store that's holding onto your configuration data. It's storing things like, for instance, which container image you have in a pod, the version, the tag of that container image that you're using. It's storing how many replicas of a pod you want in a specific replication controller. That all goes into etcd. And the top of that, you've got an API server that's reading data out of etcd and making it available in a structured form via HTTPS that you can hook into.
The one thing that I kind of took me a while to really get my head around was that almost all of your operations to Kubernetes are asynchronous. So you'll ask the API server to do something, and it will almost, not always, but almost always come back and say, yeah, cool, got that. What you need to do is make sure you go back and check to see, you've got that, great. What's the outcome of doing that? Because it could turn around and say, yep, got that, great. I've checked with the database says no. Admission controllers can kind of gatekeep some of the operations you can and can't do. They could turn around and say, no, you don't have permissions to do that. Or it could turn around and say, no, you're asking me to do something that the administrator has said that's a silly idea. So you have this idea of actually that API server is doing a bit of quality assurance and additional checking that you might not immediately realize.
Yeah, so the real way that this happens, you've got this API server, you've got a database, you've got schedulers that are checking in with the API server, and a whole bunch of operators. Those operators don't necessarily have their own unique objects. Some of those could be gatekeeping access to other objects. Some of them could be mutating other objects. So you've got an admission controller that Chris mentioned. Can I get in to do something or can I not? You can also have a mutating webhook controller. That means when a certain object is created, it's going to be passed to one of these operators that's going to mutate it and add some things that weren't there, or maybe remove things, and then pass it on to give you the final object. Chris mentioned namespaces. Those are equivalent to top-level folders in Kubernetes. A Kubernetes namespace is a group where you might choose to install a specific application and the objects relating to that. You could have security roles for that application, storage for the application. But let's run through some of the other things that you can do. Now, to access your applications, for example, you're going to need a network connection of some sort. And you can connect a pod directly to the outside world if you want to. But there's a number of more structured and comprehensive ways of doing that are a fair bit safer and easier to work with in production. So the way that you typically provide access to a pod is via a service. A service is the network plumbing in front of multiple pods, and that service gives you access to the pods underneath and deals with making sure that it's going to the right pod. And you can also use services to attach load balancers. So Kubernetes provides an integration point where you can natively attach a load balancer. You can either go to an external load balancer if you're in the public cloud and your cloud provider is providing you one, or you can even put in a load balancer for free on your on-prem infrastructure. You've also got an extension for that with storage. You can talk to your Ceph or GlusterFS, you can talk to a whole bunch of elastic block devices and similar things. And the representations for those remain largely similar due to the fact that the plugins are using this declarative outcome-based framework to skate over the implementation details so that you as a developer can say, my pod will need 100 gigabytes of storage. And you can get 100 gigabytes of storage, and whoever is managing the storage plugins gets to choose what's available to you as a consumer and how they would prefer it to be configured for your pods.
This is where I think the enterprise world and the cloud native world meet somewhere in the middle, and occasionally it's a bit of a clash. Is because you'll have, traditionally storage was fixing the problems with applications. So you'd have all these replications and enterprise storage and very expensive boxes. Now my developers are building cloud native applications. These are self-resilient applications. So you no longer need storage to fix the inefficiencies of applications, because applications have massively modernized and are looking after themselves. But these two teams aren't talking to each other. So you've got someone building an application that self-replicates, self-heals, and all the rest of it, and you've got storage that self-replicates and self-heals. You have something that you might call a write multiplier. Every time you do a write from your application is handling multiple writes. Each one of those writes is now being written again in duplication on your storage, and perhaps replicating over to DR as well, which your application might also be doing. And you have this kind of clash, and sometimes we've over-engineered the data center so much that actually the option to not do enterprise storage can be quite hard to do. I've certainly worked places where that's the case. You cannot choose a non-enterprise storage solution.
Yeah, and there's definitely some situations where you get to Kubernetes in particular where enterprise storage really is just a millstone around your neck. It doesn't fit anymore.
This is one of those areas that confused me for a lot, and to be honest, still confuses me. There is a lot of options. So I think in Kubernetes, there's a few things that are fully opinionated, as in this is the way, there are no options. And then there's a lot of things that are, well, do what you want. Storage, networking, And then there's a whole bunch of other things that you can extend Kubernetes with. We talked about admission controllers, there's security controls, there's log drivers, there's all these different things that arguably you need to run a full-blown Kubernetes server. And I think this is where we get into a topic around kind of that the opinionated versus the freedom of choice. There are some, if you want a simple, relatively simple next finish Kubernetes experience, you can go for things like OpenShift. Rancher certainly is one of those things, or a fully managed Kubernetes service, GKE, IKS, EKS, AKS, etc., etc. These simplify things dramatically, but with that opinionated nature, you lose control. And arguably, you lose portability. I cannot take a workload that was deployed into Amazon's EKS and lift that up and move it directly into OpenShift, and then lift it up and directly drop that into Rancher. I fundamentally can't do that because they are so opinionated in the way that they've built their systems. There are things I can do to make it portable, but by default, they are not portable.
This might mirror what people have done with previous IT systems, where there's a core of things you definitely need, and there's lots of spangly baubles that are technically optional, but you end up pulling in just in case because you think it looks kind of cool. And I think with the public cloud and Kubernetes, that poses a big risk because every time you pull in one of those spangly public cloud baubles, it ties you to that implementation. So you either need to be very careful with what you're using and use your persistent volumes, use a storage class with relatively little non-default options, use a simple basic service with a load balancer, and that's about it. Or you go the whole hog and you deploy your own Kubernetes on top of virtual machines in the public cloud using something like Rancher or another service. And that will give you absolute portability, but maybe you lose efficiency. And it's up to you where the cost savings lie. Are you going to be able to run your public cloud more efficiently if you buy virtual machines, or is it worth paying the extra charge to run a Kubernetes service on the basis that you can actually scale it all the way down very, very easily, which you can't do with virtual machines? What we're really trying to demonstrate here is that getting up and running as an individual developer is very straightforward. If you want to grab something like, I mentioned K3S a few times, we mentioned Podman as well, even OpenShift, quite straightforward to set these up and run with them. And there's a lot of for free options. Then you can start learning. And if you're doing it on a piece of old hardware, like an old laptop you've got, nothing's going to go wrong. You can break it, you can wipe it and try again, right? So I'd say grab something and try and learn and see how far you get.
Definitely challenge that nothing's going to go wrong. Everything's going to go wrong. And that's part of the learning. As we start using Kubernetes, there is going to be looking to put more and more applications into Kubernetes. At some point, you will have the idiscussion of, should we put stateful applications into Kubernetes? If you think back to what containers are, they're designed to be immutable, idempotent, all those things.
It became so good at marshalling applications that people rapidly decided that really database was probably just another application they should put into Kubernetes. And once that decision had been made, and people had started moving in the direction of moving their databases into Kubernetes, a flood happened. And we saw people just move the entire application in there very quickly. But there's still some friction there. And people are always very, what about the performance? What about the latency? What about the IOPS? I can tell you, as someone who's personally attached NVMe over Fabric disks into Kubernetes, that the performance I can get from a pod is the same 48.3 gigabit per second that I could get on the bare metal host, right? Direct into a pod. So the performance is there. But the question is, how do you want to manage it? And it's going to be back to what Chris was saying. You need to talk to the rest of the folks in your business, because you're going to be trying to explain a new methodology for accessing and manipulating, maybe even doing replication snapshot operations on that storage, to a team that's inherently manual process focused, mature, and often a little bit reluctant to change because of the risk of data loss, a very real problem that team has to deal with day in, day out. And you need to get those teams communicating to solve that problem.
One of the challenges that I haven't seen solved particularly well, despite what people might sell you on, is what we call day two operations. So this is, you've got Kubernetes up and running, you've got applications running in there. Now you need to operate it. Things like, okay, I've got to run and maintain this. How do I know that my cluster is healthy? Of course, you've got to do monitoring, but the way you monitor it is turned around. Google have got a great book, the SRE, Site Reliability Engineering book. I think it's still available for free. But they talk about the golden signals. You've got kind of three core types of monitoring strategies. You've got the golden signals, you've got red, and you've got use. These are just ways of approaching the monitoring of the health of your applications. But that's just monitoring. Then you've got things like upgrades. How do I do rolling upgrades across my cluster? Not just of the applications, but the underlying Kubernetes itself. And then because you've got this extensibility of things like networking and storage and mission controllers, all of those are different components that need managing and maintaining and upgrading every now and again. We touch monitoring, but you've also got to think about observability in at large. So that includes logging, that includes in application performance management. You've got to worry about security. You want to look at things like runtime security. You want to look at permission control. You want to look at secret management. There's a lot of complications in what happens when you actually start running them. And I feel like the industry is so interested in getting people into containers that day two side of things is often kind of just brushed away. So, oh, don't worry about that. That stuff's easy. Just get it up and running first.
That day two stuff should really be considered when you are choosing which Kubernetes system to use. That should be a big factor, right? Not how shiny it is or how many whizzy things there are in the UI. Falling forward or deploying a new cluster is typically an easier methodology than rolling back.
And if you've got all of your application deployments packaged up into a GitOps, kind of a nice pipeline methodology, deploying a new cluster shouldn't be a scary prospect. This is where some of the challenges of stateful applications come in, and some of the concerns around stateful applications is that application mobility.
Together with the topic of immutability, scaling is often cited as a reason why people use Kubernetes, because ultimately scaling is just a dial you can turn in Kubernetes. And it's done using the same type of controllers that we've talked about previously. You've got a template for what you want to deploy, and the number of instances you choose to deploy are simply an attribute fed to the controller that manages those templates. So you can go from 1 pod, 10 pods, to 100 pods. All you need to do is make sure that there's enough CPUs allocated to your environment to make that happen. Make sure that you're testing all these things before you go into production, as we always say. It can be very easy to misinterpret data and accidentally scale things up, so be careful.
It's important to look at what those scaling metrics are. So by default, you can scale on things like CPU usage and memory usage, but that may not be a good metric to use. You've got one of the operators is called the horizontal pod scaler. And what you can do is if you've got good monitoring data, you can feed that into the pod scaler. If you're looking at things like end user response time, you'll see this talked about a lot, is the idea of observability and good metrics. Getting your head around that is one of the more bigger challenges, I think, that is faced in, not unique to Kubernetes, but it's certainly a play there, but just in the modern application world, it's really important. I feel like each of these pluggable architectures to Kubernetes, we could do an entire episode on and deep dive into it. There's lots of great resources out there. Stephen, any key takeaways for you?
Really just have a go. Download one of these easy start versions. I think Rancher's K3S is a good place to get started. It gives you single binary. You don't have to worry about configuring too much, and have a go. It might help to use Helm to get a few templates instead of reinventing the wheel.
And don't be afraid of breaking stuff. It is going to go wrong. Knowing what happens is really important. Knowing what failures to look out for, where to troubleshoot stuff. Thank you very much for joining us on this journey. If you are watching us on YouTube, don't forget to like and subscribe.
That's all, folks. Have a good week.
Thanks all.